Now let's reiterate what we mean by torque. Torque is the rotational equivalent of force. It is what causes an object to rotate. Now we'll get back to this in a little bit. Any force applied to an object where the line of action does not pass through the pivot or center of mass of a freely moving object will cause a rotation. Okay, we'll figure that out in a little bit. Now, again, we have seen this in a previous recording. Torque in magnitude is a force times a lever arm, F times R. What we call the lever arm, and sometimes we call the moment arm, it is the shortest distance separating the line of action of the force from the pivot point. Another thing that's important, like force, torque is a vector. In the simplest cases, when the axis of rotation does not change, we use the direction of rotation for the sign of the vector. Like counterclockwise would be positive and clockwise would be negative. But in more complicated cases, when the axis of rotation changes, we'll have to use more sophisticated notions. Okay, what is the line of action? Consider these forces. We have F1, F2, F3, F4, and F5. The line of action is the line along which the force acts. Look at F1, for example. F1 is shown through this arrow here. So what we do to get the line of action is draw a line on the force parallel to the force. That's the dashed red line here. That's the line of action of F1. It does not matter where the force starts or ends as long as the line of action is parallel to that force. Check F2, for example. That's the line of action of F2. That green dashed line. F3, the black dashed line. Note that for F3, the line of action goes through the pivot. So far, whenever I mentioned line of action, I didn't speak of the pivot. It does not matter. All what matters is the direction of the force. Now for F4, that's my line of action. Another dashed red line. F5, that's another dashed line. That's the way we get the line of action.